And the base shape repeats until it disappears. So, in a prism, I started with the base shape of a circle, right? What shape is back here at the end of the prism? What shape is right there? Another circle. In this one, what did I start with? A triangle. What shape is back here? That same triangle, right? In this one, what did I start with? An octagon. And what shape is back here? Another octagon. The shape stays the same all the way along, right? But in a pyramid, the shape disappears. It gets smaller and smaller and smaller until it goes away. Everybody understand? So if I start with a square, just draw that part of the square. If it was a prism, this bottom of the square would still be at the top, wouldn't it? Like a building. But in a pyramid, it disappears. So each level of this is just a smaller and smaller and smaller square. Everybody understand? Now, can I start with any shape at the bottom? If I started with a triangle at the bottom and I went up, I'd still have a pyramid, right? It would just be a triangle over and over and over again. What if I started with a circle at the bottom? What would I have? A cone. The circle shrinks and shrinks and shrinks until it disappears. Can I put any shape at the bottom and repeat it? Could I put a stop sign at the bottom, then put a smaller stop sign, smaller stop sign, smaller stop sign, until I had an octagonal pyramid? Yes. Is everybody cool with the difference? Pyramids disappear. Prisms repeat the same shape over and over and over again. Everybody cool? All right. Please highlight or underline the word exposed. The exposed area of a solid. That means it's everything you can see. If you take that and dip it in paint, the surface area is where the paint will cover. So, this prism right now, if I dip it in paint, everything on the outside will be covered, yes? So that is the surface area. Does everybody understand? What if I rip the lid off and dip it in paint? What will be covered? Out here and inside. Does everybody understand this? Surface area is anything you can see on a solid. All right, so let's talk about this. A cereal box. I want the surface area of a cereal box. So a cereal box is what shape? You all eat cereal. Actually, you don't. I heard recently that kids are not eating cereal as much as they used to, and the cereal companies they're losing money. Do you guys eat cereal still? Any of you? What's your favorite cereal? Vector? I used to like Vector. I can't eat Vector anymore. Nobody else eats cereal but Madeline? Hurtful. I had cereal this morning. See, that's what I mean. The poor cereal companies. What are they going to do, Damon? No one's buying their stuff. The same thing with razors. Beards got cool. Now razors are losing money because more people are having beards. More dudes are having beards. Not a lot of women grow beards. But anyway, so there's a cereal box, right? Let's call it Math O's. Oh, wait. Math X's. Because it's math class and we're always looking for X's. You can laugh. That was funny. I know a great many of you are doing this thing because you don't think you'll encourage me. I'm going to do these jokes anyway. You might as well enjoy them. So, math X's. That's what a cereal box looks like, right? That's the front of the cereal box. What's at the back of the cereal box? Another rectangle. We'll go out here like this, yeah? And it would make that, right? What is a cereal box? It is a prism, yes? What's it made of? Rectangles. How many rectangles? How many rectangles make this thing? 6. Are all 6 different rectangles? Two of them are the same, the front and the back. Well, what about this? Is the top and the bottom the same? Is the right side and the left side the same? So really, I need three rectangles, don't I? Everyone agrees, right? I have the top rectangle, which I will highlight yellow. I have the right rectangle, which I will highlight blue. And I have the front rectangle, which I will highlight green. Everyone agree? If we were only talking about a rectangle, it's 8 by 24 by 40. Where do those numbers go, do you think, on this drawing? Where would 8 go? On the bottom right here. 8 centimeters across. There you go. There's an 8. Where would the 24 go? Logically. Right? And where would the 40 go? Excellent. Now, since I only have 3 different rectangles here, wouldn't the surface area be these 3 rectangles added together? Not quite. Why? Because that's only half of it. What would I have to do with those 3 rectangles to find the actual surface area? Multiply it by 2, right? So, what about that green rectangle? That's 24 by 40, right? 24 and 40. How big is the yellow rectangle? 24 by 8. And how big is the blue rectangle? Then what would I do once I had that? Once I had those 3 numbers, what should I do with the answers? Add them together first, and then what? Multiply by 2. Everybody with me? Go ahead and do so. All of you should have been able to get to that. $2,944 watts. Now, I did that in my head. If you are calculating, please, 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 and I write it wrong. Remember how I told you yesterday I'm not doing that thing where I write things wrong to fool you? I multiplied this out and added it all in my head pretty quickly. So if I'm wrong, am I right? Okay. 2,944 watts. Centimeters what? Squared. Why is that there? Because we are looking for an area, and an area has 2 dimensions. It has a length and a width. Now the problem with saying length and width is when we stand something up, where's the length go? Now, you were all taught that the length is the longest side, right? So if I hold this paper up this way, where is the length? The top and bottom or the right and left? Top and bottom is the length, yes? What if I turn it this way? Now where's the length? Right and left, right? If I was looking at it on the ground. But when I hold it up this way, what do you want to call this distance? Say the height, right? As soon as we turn it up, everyone wants to call it the height. But isn't the height the length? Everybody understand? If you think of height as being up and down, if I stand up, I told you guys this yesterday, see who remembers. How tall am I? 5'8", nice. I'm 5'8" tall, right? Because height goes from the bottom to the top, agreed? What if I lie down? Am I still 5'8"? Of course I am, because I measure from my feet to my head, yes? But if I lie down and you say height is up and down, then this becomes my height. And I know I'm fat, but I'm not 5'8", right? Everybody understand? So you have to be careful with how you label these things. I know that most often when kids see the letter H or the word height, they think up and down. But it isn't always that, because you can always turn the shape around. Everybody cool? Now the problem with this is, how many dimensions does my piece of paper have? Does it have 3 dimensions? When you draw something, are there actually 3 dimensions? No, because it's a flat piece of paper, right? So we have to call these things something. Now, because I've drawn the cereal box this way, where would you say is the height? The 40, the 8, or the 24? You would say the 40 was the height? That's cool. Then where would you say, what would you call 8 and 24? We're dealing with rectangles, so what would you call them? You'd call them length and which? Which one would you call length, Damon? You would call 24 length. So that makes that width automatically, right? Everyone agree? That's if my cereal box is standing up like this, yes? What if I drop the cereal box this way? Now what would you call this? You want to call it height, right? And you want to call this what? Width, even though it's longer? You'd call that length, and you'd call this what? Width. Everybody with me? You have to be able to visualize spinning it around. Once you label them, that's cool. You can leave it that way. Now you'll notice I'm not giving you a formula. You all know formulas, right? Area equals length times width. Yeah, you know all those? You're going to get a whole bunch of formulas, but not until after we've done a few of these, because I don't want you jumping straight to the formula and not really understanding what L, W, H, and all those things mean. Everybody cool? So we're going to draw them out first. All right? When you see the formula for this, and you're going to write it down anyway, isn't this 40 times 24 H times L, according to my drawing? And isn't 8 and 24 length and width, according to my drawing? And isn't 8 and 40 height and width, according to my drawing? So that would be the formula. HL plus LW plus HW times 2. You'll get that. You don't have to memorize it. It's going to be on the same sheet of paper that's going to have everything on it for this test. Everybody cool? All right, let us move along then, cabbages. To number 2. Draw and calculate the surface area of a square-based pyramid. If it's got a square base, then what shape does our pyramid start with? A square. So if I were to draw it, I draw it this way, because we're going to pretend that it's 3D, right? How long is this side? 32. Which means how long is this side automatically? Nope. Square base, 32. Everybody cool? Everyone agree? Okay. And then it's going to go up. So we draw it like this. And since it's a pyramid, it disappears at the point. Everyone cool? Now, this always causes problems with kids too. How do you measure the height of something like this? Would you, A, measure up the wall, or B, measure right up the middle? Red or blue? Madeline says blue. Who agrees? How do you measure your height? Do you put the tape measure up the side of your body and over your arm and over your shoulder and up like that? Or do you measure straight up the middle of your body? Straight up the middle of your body. So the height is from the middle of the bottom, and then this pyramid, it goes straight up, yes? Have any of you been to Paris? Have any of you seen pictures of the famous art museum, the Louvre, in Paris? In that museum, there's a giant pyramid that goes downwards like this. It's upside down. It sits on its point. So where would you say the height here is? You can't go up. Where would it be? Straight down. Everybody understand? So the height is from the middle of the bottom, but then what direction do you go? In this pyramid, I'd go straight up. On the Louvre, I'd go straight down. What if I gave you a pyramid that looked like this? Where would you do the height for that one? Straight to the right. So, talk to me about where you measure the height from. It's from the middle of the bottom. But it's not the bottom, is it? What do we call that shape that starts a pyramid or a prism? From the base, and then you go 90 degrees, whatever direction it is. Because I could give you a diagonal prism pyramid, couldn't I? That went up like that. So you got to go 90 degrees away. So this is 65. Everybody cool? Okay, so let's talk about the surface area of this thing. What is this pyramid made of? What shape is the base of it? The base is the shape that repeats. The triangle repeats. The square repeats, because the square gets smaller and smaller and smaller, right? So we start with the square. Okay. And then what? How do I make a pyramid? What shape is that? What's the shape of the side of a pyramid? Triangle. How many of them are there? 4. So I got 4 triangles. Well, if I want the area of a square and the area of 4 triangles, all I got to do is think. It's pretty easy, right? What's the area of every square? Length times width. Now, in a square, aren't length and width the same? Okay, so we could call it, I don't want to use length, I don't want to use width. I'm going to use the letter B for base. And it's base times base, so it's base squared. Everyone agree? Okay. What's the area of a triangle? Anybody remember? Base times height. You got to divide by 2, because a triangle is just half a rectangle, right? The rectangle is base times height, but then you're cutting it in half. So a triangle is 1/2 base times height, right? Everyone agree? How many triangles are there? 4. What's 4 times 1/2? 2 base times height. But now we're in trouble, aren't we? Because we've used the word height here and we've used the word height here. Is this 65 part of this green triangle for height? No, it's not. Because this green triangle has 32 here. Where would you find the height of the green triangle? Is that up the middle or is that up the side? Where the red line was. That is the height of the side, isn't it? So this height, we can't call it height because we've already called this height. So this one we call the slant height. So this h, we actually write it as 2bs. Now everybody laughs when I say bs. Does everybody see how it works? I had 4 triangles. 4 times a half is 2. Everybody good? So now I've got base squared. Well, I said my base was 32, so I do 32 squared. And then I've got these 4 triangles. What math do I do here? It's the square and 4 triangles. So what math is this? Add 2. What's the base? What's the b? 32. And what's the s? Do we know? We don't know it, do we? Because this blue line and this red line create what kind of triangle? The blue line went straight up from the black line. So what degree is that? 90, which makes this triangle what kind of very special triangle? Right angle triangle. And what do we know about right angle triangles? If I write 3 letters, somebody will get it. What is it, Sayaj? A squared plus b squared equals c squared. Where's the a? Does it matter? Where's the b? Does it matter? As long as it's the other one from a. Where's the c? So, do we know this blue distance? How long is that blue line in our pyramid? 65. How long is that black line in our pyramid? This is a trick. I want to see who can figure it out. 16, you sneaky. How will I find C? (16 squared equals c squared), and then at the end we have to square root. Do that with your calculator. 65 squared plus 16 squared, and then square root the answer. All of you know how to find your square root with your calculator. I only need 1 decimal place. Just give it to me with 1 decimal place. What is it? So 67, because we'd round up the 0.9, right? Is everybody cool? Why did I show you this? Because the slant height is the hypotenuse, which is C in that formula. So now that we know this is 67, what can I write right here where I had slant height? Where can that 67 go now? Goes right in there for the S. And all of you should be able to tell me the surface area of this thing now. Remember, you don't need to memorize this formula, which would be b squared plus 2bs. Because you're going to get that formula, as long as you can work with it. Everyone is cool? So punch that into your calculator. Somebody give me an answer. That one I can't do in my head. I bet I could. But. And it's a pretty big number. What is it? Anybody? It's just calculator work. What is it? 5,312. Feet what? Squared, because I'm looking for an area. Is everybody good? Ease, bees, lemon squeezy, right? You'll get the formula, you fill it in. What's the hard part? Knowing what B, S, all that stuff means, right? That's what takes a long time. Because all of a sudden, the height can become the length. Everybody with me? Cool. Okay. A cone. Well, let's draw a cone. How does a cone start? Circle. And since it's a cone, we know it goes down and disappears, yes? Everyone agree? Okay. So this part is a circle. How do I find the area of a circle? Who remembers? Right. Pi r squared. Now, when you guys do pi, oh crap, I forgot to do attendance. They're going to yell at me. Go for Myers. You would want the summer school office. This is the classroom. Okay. No, I do not. I don't know why Betty would have sent you up here for Stan. I don't know how to do that. Okay. Okay. Pi r squared. What's pi? You've always used it as 3.14, right? Use your calculator button. Every calculator has a pi button on it somewhere. You're going to use that. And actually, I'm going to teach you something different that you're going to do for the rest of your math life. Okay? And I'll show you what I mean in a minute. So that covers the circle. But here, this is a mess. Because this part of a cone is a section of a circle. It actually looks like this. It's not quite a circle. It's not even a quarter of a circle. It's a weird fraction of a circle. All right? Now, since it's a circle, if you wanted the area, what must be involved? If you're looking for the area, a section of a circle, what do you have to use? Or what would you have to use? It's a circle, so we're going to need pi, right? Right? So this part here, which we call, let's call the rest of the cylinder, must be pi. Agreed? And since it's a circle, it must also use the r. Right? Which is radius. Now in a circle, it's r squared, so it's r times r. But this isn't a full circle, is it? So it's not r times r, it's r times s. We've already seen s. What is s? It's the slant. And what did we use to find slant? You find slant with a squared plus b squared equals c squared. So let's look at this situation. The circle part's easy. Pi r squared equals, what's the r of this circle? Read in the question. 15. And the height is 22. Is that height down the side or right down the middle? Is it blue line or red line for 22? Blue line. So what's missing from this cone that I need? Then I need pi r slant. Well, I've got the pi, I've got the r, but now I need the red line. How do I find that red line? I use a squared, b squared, c squared. So c is what? I just need one decimal place. What's C? 26.6. Now C is also slant, right? So what is going right here where I need the slant? And what am I going to do with those two numbers when I get them? I'm going to add them together to get the area. So that is 225 times pi, right? Because 15 squared is 225. Agreed? And 26.6 times 15 is 399 pi, right? Because 15 times 2, 26.6 is 399. Now, if I have 225 pi's and 399 pi, how many pi do I have? No, I got 225 of them there, and I got 399 there. So I have 624 pi, don't I? Does everybody understand what I did there? I'm going quickly, again, because it's summer school. This is the way your future teachers will want these questions answered. You will stop giving decimals for pi in grade 11 and 12, and if you go to university and do math, you will never write pi as anything but pi. Do you all understand what I'm saying? So this isn't a very good real life answer, is it? If you built this cone and you put it on like an ice cream truck and you needed to paint it, you couldn't go to Home Depot and say, I need enough paint to cover 624 pi. Could you? So you would want to find an actual answer. This is your math class answer. What's your real life answer? You do 624 times your pi button on your calculator. 624 times pi. And it's going to be something like 1,900, almost 2,000. I don't know exactly what it is. What is it? Oh, it's 1,960.35. This, that shouldn't have been read. This is your real life answer. Everybody cool? Okay, we got one more to do, and then it's break time. Draw and calculate a pop can. What's a pop can look like? What's on the bottom of it? Or the top? Circle. What's at the other end of it? Circle. What's in the middle of it? A rectangle. So, if I'm doing the surface area, there's one circle. What's at the bottom? Another circle. So I got two circles. Well, if the area of one circle is pi r squared, what's the area of two circles? 2 pi r squared. And then I got this rectangle in the middle here, right? Now, I already showed you this is a cylinder, yeah? So that's a rectangle, right? How do I find the area of a rectangle? Length, or length times width, right? So this in the middle here must have a length and a width, right? Well, the rectangle, isn't its length all the way around the circle? Isn't it? So all the way around a circle is 2 pi r, because it's pi times the diameter. That will get me this distance, but then I need this distance, yes? Right now, what would you call that? Height. What if I lay the Popcan on its side? Is it still the height? Still is, because height goes from base to the end, right? Wherever the base is, that we call our height, because height is always 90 degrees away from the base shape. So all I got to do is, I know it's 2 pi r squared. So I know the circles are 2 times pi. What's the r? It's a little tricky, this one. Say it loud, Culver. 5. Because diameter is 10, r equals diameter divided by 2. 5 squared. Now, in grade 5, when you first started doing circles, you would have used 3.14 there, right? We're not in grade 5 anymore, are we? We're in grade 10, moving into grade 11. Are we even going to use our calculator button here? We're going to do it the way we're going to do it for the future. We're going to leave pi alone. So what is 5 squared? 25. What's 25 times 2? 50. So I got 50 pi. Everybody understand? And then for the rectangle is 2 times pi times 5. And what's our height? Read the question. 20. And we're going to do this like we're big math kids. What's 5 times 20? What's 100 times 2? 200 pies. Then what do I do to get my math class answer? Adam, how many pies do I have? 250 pi. What's my real life answer? I do 250 times pi to get what? Should be around 775. What is it? 785. 785 and some decimals. Okay. Which one is right in math class? Which one do I give you full credit for? Which one? I could give you full credit for 250 pi, but isn't this also the right answer? They're both going to get you full credit. Which one's faster? I like this one. And I would practice this one if I were you, because your future teachers are going to want the answers this way. Does everybody understand? Okay, so let's recap. The base is not, you don't have to write this down, you've already written it down, is not always the bottom. The base is the, I don't even want to say foundation, the shape that repeats. Everybody understands that, yeah? The height is not always up and down. The height is always 90 degrees away from the base. Or another way I like to think about it is the height is the direction the base repeats. So if I have this cylinder right now, the base is the circle, because that's what I start with, right? The height goes away from the circle, the direction the circle repeats. If I turn it this way, the circle is still the base, because that's the shape that starts. The height goes away from it. If I turn it diagonally, the height still goes away from the base. Does everybody understand that? All right. And last thing to remember, slant height is up the side. And we often need to use Pythagoras to find it. That's the review of everything we just did. You guys sat for a very long time. Class took a little longer than it should have. You should have been practicing by now because we were marking the quizzes. You have a break coming up in 8 minutes. You may sit and talk right now and relax until your break and then go have your 10-minute break. Or you can see the next page, next section is practice of surface area. If you turn the page over, you see I have 3 pages of surface area questions. Okay? Do not do the very last one about painting yet. Do not do that. Halfway through your next block, we're going to talk about that question. Okay? Before you leave and decide to take a break, please look. This question here, you will notice, to do the surface area of that, what is that really? What could I draw right here? A line. And then I have 2 rectangle prisms, don't I? Everybody with me? What about this question? I have this guy and this guy, don't I? Same thing with this question. Right? Be careful. Everybody cool? When I say careful, I mean things like this. Is that green rectangle actually part of the surface area of this shape? Yes or no? Why not? Because it's not exposed. It's hidden away. Okay? Is that green rectangle part of this guy's surface area? Why not? Because it's not exposed. Everybody understand? So if you're going to use the formulas, you got to think some of that part of that formula isn't actually part of the answer. Everybody with me? All right. After your break, I'm going to give you a separate sheet of paper with all these formulas and drawings on it. So you don't even have to remember what the things are called. Everybody cool? And I have 9:10. Break is at 9:15. But you may have the next 5 minutes off in class. You just can't leave. Everybody cool? All right. Or you can start your work now. Whatever you want. Up to you.